All right, section 3.5, operations on functions. What we're going to be doing in this video is we're going to be forming composite functions and find their domains. In this first video here, we're going to be doing with composite functions, but with number inputs. All right. The other video, the next video after this, will deal with generic inputs. All right, so number inputs is what we're going to do. Now, what in the heck do you know I mean by that? Well, first of all, we need to understand what a composite function is. Right? Well, first of all, the definition is G open circle F, not a dot, it's an open circle. Dot means multiplication or product. This means composition. Right? That's how they write it sometimes. Again, order is important here. So if they have f of g of x, all right. And so what it means when it's written like this, it looks like that. How you say this is g of f of x, g of f of x. That's how it's pronounced. All right, see, look, learning a whole new language here. All right, now, order is important. Again, to do these, you must be given, in this case, two functions. Let's say f of x is equal to 4x squared plus 1. G of x is equal to 1 over x plus 2. All right. What we want is we want to do G open circle F of 2. G of F of 2. Or we can write it this way. Right? What composite functions is like doing substitution, but with some steroids involved. All right? Or drug enhanced, performance enhanced drugs for substitution. Okay, that's really what we're doing. What this says is you always work on the inside, work your way out. So in other words, we're going to take f of 2. We're going to do f of 2. Well, 2, I'm going to take the value, the number input, this is the number input, I'm going to plug it into f. So f is here. So that means I'm going to put 2 in for x here. So that means it's going to be 4 times 2 squared plus 1. So I'm substituting 2 into this function. All right, so here I get 4 times 4 plus 1, so that gives me 17. Now I have that value, so I can replace this with 17. Now here I take 17 now, I'm going to plug it into g, in the function of g. So here's the function of g, I'm going to plug 17 for x here. So this becomes 1 over 17 plus 2, 1 over 19. So there is your value. So when you have a number input, your output is also going to be a number. So my output will be a number as well. Okay. That's what composition of functions. Okay. Again, let's try it another one. Let's try another one. Let's do, we'll use the same functions. Let's do f open circle g of negative 1. In other words, I want to do f of g of negative 1. Look here, I changed the order. So that means I'm going to plug negative 1, the number input, into g. So I'm going to go into the function of g. Where is it? Right here. I'm going to plug negative 1 in for x. So g of negative 1 will give me 1 over x, which is now negative 1, plus 2. So that gives me 1 over 1, which is 1. So this right here now becomes f of 1, because g of negative 1, which I did, gives me 1. So now it means I'm taking 1, the number input 1, and I'm plugging it into the function of f. It goes right here. So this becomes 4 times 1 squared plus 1. 1 squared is 1, 4 times 1 is 4, so therefore I get 5. And there's my numbered output. Okay. Let's try one more. I like this one. You'll probably see an extra credit problem on Google Plus, similar to this type of problem. All right, so first of all, let's define the two functions. 4x squared plus 1 and g of x is equal to the square root of x. All right, so let's do f, open circle, g of 3. In other words, we're going to do f of g of 3. All right, so this tells me I'm going to put, oh, I'm sorry, don't want to do that yet. F of g of 3 minus 2f of 1. There we go. Gotta make it fun. So, this right here says f of g of 3 minus 2f of 1. Alright, so that means I gotta do a composition of functions over here. So I'm gonna do g of 3. So g of 3 is square root of 3. Well, that's nice. So this right here, I replace this g of 3 now, I'm placing it with f of, whoops, square root of 3 minus 2f of 1. Right. So in this one, I'm going to put the square root of 3 into the function of f. So f is 4x squared plus 1, so I'm replacing this x with the square root of 3. So now this problem becomes, or this portion becomes 4, the square root of 3 squared plus 1 minus 2, a function of f. All right, so I'm taking the same function this time. Instead of putting radical 3, I'm going to plug 1 in. So it'd be 4 times 1 squared plus 1. Now it becomes order of operations. So here this just gives me 3. 3 times 4 is 12 plus 1 minus 2. 1 squared is 1 times 4 is 4. 4 plus 1 is 5. That gives me that. And 12 plus 1 is 13, and 13 minus 10 is 3.